know, look at the order of operations. If you don't have a calculator, this is -2. This is 6 squared, right? So times 36, and then minus 3. So -72 minus 3 would be -75. It's big without a calculator. I probably wouldn't have you do 2 times 36. Number 2 is just what? 49 minus 4 and then plus 8. So 45 plus 8 is 53. Is that what you got? I'm into math here. Let's see. I'm going to get rid of this 5 to the 0 power. That's just 1, right? So this is -27 plus 16 plus 1. -27 plus 17. So that'd be -10. Is that what you got for that one? Are people trying it with mental math? Let's see. This is 5 minus 1 is 4 divided by 2 cubed, so 4/8. Or if you wanted to simplify, it'd be 1/2. 4/8 would be acceptable. This is the distributive property. 5 squared is 25 and 2 squared is 4. That's fine if you want to leave it as an improper fraction. It doesn't really reduce. Number 6, I've seen this one before on like social media. Will be like, what answer do you get to this problem? And a lot of people say one answer and a lot of people are debating and say the other answer. When it is parentheses, obviously you would know to do parentheses first, right? So I would have 8 divided by 2 times 4. But what part do I do first? If you do 2 times 4 first, you get 8 divided by 8, which is 1. And that's what your brain tries to think about doing. But multiplication and division, you do in order from left to right. So technically, what you do first is 8 divided by 2, that gives you 4, times 4 is 16. So the real answer is 16. And if you said it was 1, I know what you did. But make sure you do division and multiplication in order from left to right to get the right answer. And you can prove it using your calculator. So 8 divided by 2 times parentheses 2 plus 2 gives you 16. Okay, so graphing. People need a little bit more practice on graphing. So there is on the quiz review after lunch, there's some graphing practice. So it says graph the exponential function, include asymptotes, and state the domain and range. What is the parent function? 3 to the x for this one, and 1/4 to the x for this one. So let's dive in. What does 3 to the x just look like? So 3 to the x, before I even start, has an intercept at 1. It goes over 1, up 3, and -1 and up 1/3. So this is the parent function for 3 to the x. What are the other pieces of this equation? X minus 4. What does the x minus 4 do? Does it shift it right or does it shift it left? So this makes me go right 4. And what does this plus 1 do? Shifts everything up 1. So remember, this is kind of like parentheses, it's backwards. This is just up or down. So I would actually take each one of those dots and count, right? 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. The other important thing that moves is your asymptote. So your new asymptote, the equation is y equals 1. So that's important. If you shift up or down, your asymptote is also going to shift up or down. Anyone want to take a stab at the domain and range for that function? What do you think the domain is? All real numbers. So my domain is all real numbers. What about my range, my y values? Y strictly greater than 1. Yes. Because you can't touch your asymptote and y is above the asymptote of 1. I think graphing is probably the hardest part because it's what people struggled on from unit 1. So if you can get 5 out of the 6 questions right, I mean, you'd have, let's say you had a 555 out of 100, you'd have a 93. But hopefully you can study the graphing. That's what homework 1 reviewed was the graphing. So try to get homework 1 done for tomorrow. 1/4 to the x, this is what I was talking about with Nora. If I just look at the 1/4 and I don't look at the information, the function 1/4 has an intercept of 1. At -1, you'd be at 4, and at +1, you'd be at 1/4. This is a decay curve. But the negative in front does what? Flips it upside down. So this point is going to be down here, and down here like that. Oh, and then I should dot in my asymptote to get full credit. So y equals 0 is my asymptote. And can someone different say the domain and range of this one? What's your domain for any exponential function? So my arms can open as wide as I want, right? It keeps going this way. So my domain is always all real numbers. So what's my range? So here's my y values. So what does y have to be? Do you know it and you're just not saying it? Strictly greater than 0. So y is strictly greater than, or sorry, strictly less than 0. I wrote it correctly. I said it wrong. The y values are strictly less than 0, meaning they're below that axis. All right. You guys have 3-ring binders that I should pull punch stuff? I forgot that this was supposed to be, this was 306B, and then the one I gave you was 306C. See what happens when I don't give it to you all in the packet at the beginning of the unit? I'll get this organized, get this organized. Scientific notation should be something you use in science class, but it directly relates to exponential world, so it's not like a focus. But I would be remiss if I didn't mention it and just have us practice it one time. So there might be like, a scientific notation question on a quiz or a test. But it's really just writing things out correctly using scientific notation. So scientific notation is a way to express really big and really small numbers. So like the distance from the Earth to the sun is 93 million miles. So usually we just write it in scientific notation so that we don't have to take up the space of all those zeros. I'm not going to worry about, what is it called, sig figs in chemistry, right? I don't necessarily know how many sig figs to use on things. So I'm just going to use like, if they give you a few decimal places, I'm going to use the decimal places they give you, but don't tell Miss Bertrand. I don't want to mess you up for whatever sig figs you use in chemistry. But if you are going to make your number between 1 and 10, so I would take my number 9.3 because that is between 1 and 10. And then I think to myself, how many places to the right do I have to move my decimal place? So 1, 2, 3, 4, 5, 6, 7. I just move my decimal 7 places to the right. I really need to multiply by 10 to the 7th power. If that slides the decimal place 1, 2, 3, 4, 5, 6, 7 places to the right. Is that how you were taught scientific notation? Okay, let's do number 2 together. Like I said, I'm not sure about 2 things. If I did 3.23 as my, that's between 1 and 10, right? How many places do I have to slide my decimal place? So 1, 2, 3, 4, 5, 6, 7, 8 this time, right? So times 10 to the 8th. So multiplying by 10 gives me a really big number, like billions or millions. But number 3 is starting out as a really small number. I still need to use a number between 1 and 10. So I'm going to use the number 2.7. But this time, I'm thinking about sliding my decimal places to the left. So that would be 1, 2, 3, 4, 5, 6, 7, 8 units to the left. So this time you write it as 10 to the negative 8th, meaning it's a really small number. I'm sliding it 8 units to the left. And then let's see, 365 would be what? 3.65 times 10 squared, because that would move it 2 places to the right. All right, you try on 5, 6, and 7 to write those out into a common number, meaning put it out of scientific notation. See if you can correctly write number 5, 6, and 7. Yeah. Oh, did I count wrong? If I start here, 1, 2, 3, 4, 5, 6, 7, 8. Are they starting between the 2 and the 7? You're not starting after the 2 and the 7. This? Yeah. No, because you didn't slide the decimal past that 0. Right? I could write the number like this. I don't need to write a 0 there. Writing something in scientific notation? Do you feel like you can't do it yet? No. Oh, I mean, I can leave scientific notation off, but it'll definitely be on your test. Or I could put it as a bonus. Is it hard? Have you not done scientific notation before? Didn't really use it much in chemistry? They would. So you would write your answer like this. Yeah. Oh, and your calculator gave it to you in scientific notation? Oh, really? All right, try 5, 6, and 7 though. Yep.
This one, because I was just filling
Oh,
in
yeah.
my packet. I just wanted to know so I can grab things.
So 3 to the x. You want to just dot it in pencil first?
Yeah, sure.
So 0, 1, 1 comma 3, and negative 1, 1/3. That would be the parent function for just 3 to the x. Because if I plug in 0, right, I get 1. If I plug in 1, I get 3. Okay, so then this shifts you to the right 4, and this shifts you up 1. So I just count 1, 2, 3, 4, and up 1. 1, 2, 3, 4, and up 1.
And to get this function, you plug in.
I like to make a table of values, negative 1, 0, and 1. So 3 to the negative first is 1/3. 3 to the 0 is 1.
Those are the numbers for the regular function?
Yeah, this is for 3 to the x. I don't do it for the new function.
Oh.
I just do the parent function and then I slide it wherever it needs to go.
Oh, okay. Thank you.
Okay, so let's see. This one should be 3, 6 with 1, 2, 3, 4, 5 zeros, right? We're moving it 2, 3, 4, 5, 6. So that would be what? 3,600,000. This is going backwards by 5 spots, so I would need 4 zeros, then the 3 and the 2, right? Because that would be from here 1, 2, 3, 4, 5. Yeah, because I'm thinking in my head that this is my first slide to the left, right? And then isn't this my first slide to the right over here? So to go 6 spaces, I would need 5 more zeros because I've already gone 1 slide to the right, and this one I've already gone 1 slide to the left. So this one I only have to go 1 slide to the left, right? 0.68. If you, I mean, you'd have a calculator to do a question like 8 and 9. I just wanted to show you that we can use our properties of exponents because if I just ignore for a minute my x to the 5th and x to the 10, 10 to the 5th and 10 squared, what do I get when I just multiply 1.8 on my calculator times 3.6? So do you get a number between 1 and 10? Yes, you get 6.48. What power of 10 do I have to multiply by if I have 10 to the 5th times 10 to the 2nd? Using our rules, it would be the 7th power, right? Because they're next to each other. So when you use scientific notation, you're you're allowed to multiply the coefficients together and then just kind of add the exponents together at the end. Same thing with dividing. So I can use my properties of exponents. I can just take 4 and divide by 2. That would give me 2, right? And then what was the rule? If I have a power of 12 over a power of 3, how many powers are going to be left? Remember the rule for division? You're canceling some of them out, right? How many powers of 10 are going to be left? 12 minus 3 is 9. So it would be 2 times 10 to the 9th. So just to show you, you're using the properties of exponents that we learned over the last couple days, right? 10 to the 5th, 10 squared becomes 10 to the 7th. 10 to the 12th, 10 cubed becomes 10 to the 9th. All right, what's 6 divided by 2? 6 divided by 2 is 3. Do you remember what I said to do when you've got a bunch of negatives hanging around? Flip where they are, right? So 10 to the 6th would go to the bottom, and 10 to the 8th would go to the top. I can make them positive because I moved where they were. What power of 10 should be left over here then? This is an 8. This is a 6. They're going to cancel. And how many powers of 10 will you have left? 10 squared. Well, it was negative, but I moved it to the top and made it positive. I guess I'll see you after lunch. That's why I was saying you move 10 through 13 on this page, write them in scientific notation, convert them out of scientific notation. We're going to skip doing notes on E, 308. I might show you the video if I have time at the end, but our focus should be on getting the 307 quiz review done after this. So first, oh, you know what? For the sake of my video here, this one should have been 6.7. Can you check the go over 7.5 times 10 or times 10 to the first? And 5.1 times 10 to the negative 4. Do we do okay on those? And then 1, 2, 3, 4. When I slide my, right, if I'm starting here, 1, 2, 3, 4 to get there, right? Not to the other 0. So this one would be what? 406 million? Are you just checking? At least if you check your answers. 3.7 times 1.8 is 6.6 times 10 to the 15th. And then 22.2 times 0.25. 5.55 times 10 cubed. You guys got those? This would be 3 times 10 to the 9th and negative 4 times 10 to the negative 7. You end up with 10 cubed in the denominator on this one. So you end up with negative 4 in the numerator, 10 to the 7th in the denominator, and it's 10 to the negative 7th because you're dividing by 10 to the 7th. Negative 4 times 10 to the negative 7. Yeah. All right, so you're returning to the quiz review, which is page 307. Let me just skim through 307. So you have to do the graph, you have the whole front page is graphing, solving simple, evaluating fractional, and exponent rules. So there's no scientific notation on the quiz review because I kind of forgot about it. So I might throw a bonus scientific